Hello and welcome back to the data science track at PyData Global. We have a very exciting talk up next from two fantastic speakers, Jacob Tomlinson and Melody Wang, who are going to be talking about the art of wrangling your GPU Python environments. And without further ado, I'm going to hand over to them.
Great, thank you. Hi, everybody. Thanks for coming along to this session. So we're going to be talking about the art of wrangling your GPU Python environments. This is kind of talking a bit about the complexities and the challenges of I want to do some Python, but I want to use GPUs in this environment. What extra things do I have to think about? What other things do I have to install? And kind of what are the various pitfalls and how can we work around those? So just to introduce us a little bit, my name's Jacob. I've got Melody here as well. We both work on the Rapids team at NVIDIA. Melody's been interning with us through the summer, working on a project to try and improve the kind of workflow for kind of average data scientist in using these GPU software environments. So Melody's going to run you through most of the talk. You'll probably hear a bit from me later, but I'm also going to be hanging out. I'll be in the Q&A, so please feel free to ask questions as we go along. Anything you want to learn more about, I can be kind of typing away in the chat, but I'll hand over to Melody to get going.
Hi guys, I'm Melody and I'm currently a senior at Carnegie Mellon, and this is my first talk at a PyData conference, so I'm super excited to be attending and getting involved in the open source community. But let's just go ahead with the talk. For those who aren't familiar, Rapids is an open source suite of libraries and tools for GPU accelerated data science and machine learning. It's really easy to use and high performing. Everything is run under the GPU under the hood, and we emphasize a vibrant Rapids community, and we encourage contributions and collaboration from developers and users around the world. So why this is important is because in the current day, enterprise applications have become increasingly demanding. And as the world digitalized, the amount of data processed by these applications have also skyrocketed. So from personalized recommendations that see over 1 billion visits to e-commerce sites daily to LLMs like GPT-4 that require trillions and trillions of tokens for trading. And then there's billions of product store combinations weekly at Walmart to forecast fraud and detect fraud in 1.9 billion credit card transactions per day. So looking ahead, this upward trajectory is slated to continue across these cases. Genomics as a field alone is estimated to generate between 2 to 40 exabytes of data within the next decade. And the domain of cybersecurity witnessed a 50% increase in cyber attacks alone. So you see the demand for accelerated computing is insatiable. So right now, our accelerated computing ecosystem has an abundance of libraries and toolkits that allow users to pick and choose components relevant to their workflow, and they're specialized for different functions to maximize performance. So Rapid's modular approach with focused libraries for different tasks, so such as CUDA and QML, which we'll get into. So this is an example of CUDA, which is a Python GPU data frame library for loading, joining, aggregating, filtering, and manipulating data. Basically everything that Pandas does. And it does provide a Pandas-like API that are already familiar to data engineers and data scientists with basically zero code change. So you can easily accelerate your workflows without going into the details of CUDA programming. So as you can see here, for the CPU time using just Pandas, it's around 59 seconds, but on the GPU, it's 742 milliseconds. So you can see quite a drastic acceleration here. And on the other hand, for QML, it's a Python GPU machine learning library that implements ML algorithms and mathematical primitive functions. And this shares compatible APIs with other Rapids projects. So you can use these libraries seamlessly together. And CUML basically allows users to run traditional tabular ML tasks on the GPU without going into the details of CUDA programming either. And in the most cases, it matches the API from scikit-learn identically. So you also don't have to learn like new syntax. So in the recent years, Rapids has been rapidly adopted across these industries. For example, Adobe uses Rapids Accelerator for Apache Spark for like more than 70% cost savings and 33% performance improvement. While AstraZeneca uses cuGraph to turn days into seconds. And they run PageRank, the PageRank algorithm, in less than a second on their knowledge graph. And then Walmart performs 100 times faster feature engineering and 20% faster model training using Rapids, Dask, and XGBoost. So since its launch in October 2018, Rapids has been battle tested on the most challenging workloads and integrated with the most innovative tools, and is now backed by a huge community of contributors on GitHub. And as you can see here, 25% of Fortune 100 companies have adopted Rapids already. So Rapids is all about enabling data scientists and engineers to easily leverage the power of GPUs for like a faster and more efficient workflow. But achieving this goal isn't just about providing great libraries like cuDF and cuML. It's also about ensuring like that users can easily set up their environments to smoothly use Rapids in their workflows. So if you've ever tried to configure a GPU environment, you've probably faced issues like outdated drivers or conflicting dependencies, or even like the dreaded, oh, it works on my machine scenario. But however, like GPU environments are really complex and they typically require GPU, drivers, CUDA toolkit, packages, and a variety of other dependencies. And therefore, setting up and maintaining this like Python stack can be really daunting, especially when it involves like navigating dependencies and compatibility issues. So, like furthermore, like pre-configured like environments, like Docker images or cloud setups, can actually backfire because when something breaks, diagnosing the root cause becomes harder when users have like less visibility into how the environment was configured in the first place. These are just some scenarios where things can go wrong. If there's like version mismatches or incompatibilities that do not align with your project's requirements, this can lead to runtime errors or like degraded performance, and also like limited customization on your part because pre-configured environments can lack the flexibility to add or update specific dependencies without breaking the whole setup. So it can be very confusing to navigate all of this. So how do we address this issue? Here are some things we've tried so far, which Jacob is going to talk about.
Yeah, great. Thanks, Melody. So there's a whole bunch of things that have happened within the Python ecosystem kind of since Rapids has been around to try and improve some of these things. And the world is a lot better than it used to be. So if you heard of Rapids a few years ago and you tried installing it, you may have run into like a bunch of these issues. And things have kind of moved on and progressed since then. And there's a bunch of stuff that's happened that we're really proud of to, either that we were part of implementing within the community, or, things that were kind of, we were able to be a voice and participate in. One of those things that happened in the Conda community was adding this concept of virtual packages. This is something that Anaconda did on their side, but it allows the package solver to, when you install a package, it can specify a dependency on something that's managed outside of the Conda ecosystem. And kind of at solve time, it can look at what you have on your system and figure out what version it is, and then use that in the solve. And so things that are kind of outside of your ecosystem, like CUDA itself, or what GPU you have, or kind of what operating system you have, anything that's kind of managed outside of the Python environment and is beyond the bounds of pip and Conda and things, virtual packages kind of still allow those to be depended on explicitly. So you can add your Conda packages kind of an explicit CUDA version that you need, and the solver will kind of figure that out correctly. And that's been really critical in being able to manage these kind of software environments where you've got this thing that's been provided to you already. You've got this driver, you've got this CUDA toolkit that you probably installed through some NVIDIA tool or script or something, and then you're trying to add this Python environment on the top. If we go to the next slide as well, please. So the other thing is building packages that are kind of, you don't have to compile at runtime, right? So through the Conda Forge community, so much effort has gone into building packages that are GPU aware, adding all the kind of tools that you would hope for from the CUDA ecosystem. So CUDA toolkit itself is packaged and available on Conda Forge. A lot of the build infrastructure side of Conda Forge now has GPU builds and lets you kind of compile packages there that have these kind of GPU dependencies that you need to build for various different versions. And lets us kind of, having everything available in Conda Forge makes it really nice for other packages to come in and kind of operate within this one ecosystem. If we go to the next, yeah. So like, a bunch of things have kind of changed and moved, and you've got all these libraries within the Python ecosystem, PyTorch and TensorFlow and Rapids and CuPy, and everybody kind of working together to try and improve kind of these slightly more complex environments and these more complex dependencies. And there's like a bunch of exciting stuff in the pipeline as well that's just going to keep making this kind of a more frictionless experience. And so if we go to the next slide, there's like a few PEPs that are interesting, particularly around package indexes and where we're getting different packages from. It makes it easier for us to put some packages in PyPI, but also have other packages in other indexes. But also like extending that concept of the kind of the virtual packages and the various package metadata information from Conda and Conda Forge over into the pip, UV, PyPI ecosystem, being able to add arbitrary metadata so that you can specify things, which operating system you support, which CUDA version you support, kind of all these extra things that you might want to be able to flag and build different packages for, is really great and supports us in the GPU ecosystem. But also one thing we've really benefited from on the Conda side is being able to have like shared low-level dependencies. So being able to have like a compiled library that you just install once, and you have a bunch of different libraries depending on it. Being able to move that into the PyPI pip ecosystem is going to really help reduce like the size of these environments, because at the moment, if you come and install a bunch of GPU packages, you'll find that each package is quite big. And if you kind of dig deep into them, you'll find that they have a lot of duplicated files within them because they're having to pull in these kind of low-level C dependencies that they need, but they're not able to share those between them. And things are kind of improving both on the packaging side and also on the tooling side to make it so that you can install PyTorch and you can install cuDF, and they can share the same underlying, C library from the CUDA toolkit or whatever. The other way that we're really seeing nice improvements is just having platforms do all of this work for you. So I think now that GPUs are well established as this kind of part of our everyday life and within a data science workflow, like at least some tool you're going to use is probably going to need the GPU to get good performance out of. Having platforms like Google Colab or Databricks or whoever it is, like adding these packages as standard and making them available and testing these environments makes it much easier for users to just go and get started. Because the hardest thing is when you get kind of a partial environment with some things in, and then you need to add more yourself to it, but you don't know what you've been given. So I think having these kind of full stack solutions where you just have all the things installed that you need, and you can just get on with actually thinking about solving the problem you're trying to solve and not worry about any of these dependencies is a great place to be.
Cool. So, like the previous tactics are effective, but only in their subparts. So, how do we make sure that they work across each other and fill in the potential gaps? So, now introducing like Rapids Doctor, it acts as a meta diagnostic layer that works across all these components to ensure a smooth setup and operation. And the value add here is that by bridging these gaps, Rapids Doctor ensures that the entire stack, from the hardware to the system level configurations to the package level dependencies, is cohesive and reliable. So this minimizes setup time, troubleshooting, and user frustration, and it enables smoother adoption in the use of GPU accelerated data science tools. So it acts like as this layer that like ties everything together. So for a quick demo of just like a work in progress of what we have. Let's see. Okay. Cool. So this is just a proof of concept of what Rapids Doctor is. Let's see if I can. Cool. So on the left here, we have an environment that is broken without like the necessary installations needed. So as you can see here, I run Rapids Doctor on my command line, and it does a driver check, OS check, GPU check, NVLink check, and just checks for a bunch of requirements that are either like required or recommended. And you can see that nothing here is installed. It's just run on my local machine. But on my remote server with actual GPUs and CUDAs and drivers, if I run Rapids Doctor, it loads the checks, and as you can see here, I have the right conda version, right CUDA, Docker, OS, GPU. Everything looks good from my end, and that is exactly what we want. We want to identify which parts look good and which parts aren't. Cool. So going back to the presentation. Yeah, as you can see here, there's a lot of difference between a healthy environment and a broken environment that Rapids Doctor kind of like diagnoses. It serves to ensure that hardware and software environments meets the foundational requirements for Rapids. There are a bunch of system requirements and recommendations. It checks that required hardware, drivers, and OS are compatible and recommended compute capabilities are met. Basically, for GPU, it confirms the presence of a compatible NVIDIA GPU with sufficient compute capability for Rapids workloads. And for CUDA drivers, they flag outdated drivers and provide specific instructions for upgrading, and then ensures that the OS has necessary libraries on Linux or compatible dependencies on Windows and Mac OS. And a highlight of Rapids Doctor is that it goes beyond just like flagging problems, but instead it also provides solutions tailored to identified issues. So it diagnoses and pinpoints problems like mismatched CUDA versions, missing dependencies, or just insufficient GPU memory, and then suggests exact steps to fix issues, like updating drivers or installing specific packages. So this saves a lot of time by minimizing guesswork and troubleshooting, especially for users less familiar with GPU setups. And then our third design highlight is the ability to plug in your own checks through a Python entry point system. This is a modular design feature where each Rapids library, such as cuDF or cuML, or Morpheus, and even more to come, they have their own like diagnostic plugin that validates its specific requirements and configurations and ensures that everything's compatible with the Rapids ecosystem. And it's very extendable because Rapids Doctor can support new libraries in the future through additional plugins, and it ensures like a smoother workflow by reducing the likelihood of maybe just like library specific issues. So on the horizon, we just seek to make Rapids Doctor a really comprehensive tool for ensuring compatibility and performance across like a variety of different workflows and environments. So we want to include more integrated checks with different libraries, as mentioned before. We also want to perform more platform checks, such as with Docker, Kubernetes, etc., and then integrate it in cloud, such as SageMaker, Vertex, or Databricks. And yeah, that's basically the end of our talk. Thank you all for coming. And we would, since this is just like a really new tool that we've been working on, we would appreciate like any feedback or suggestions and questions as well.
Okay, so we've got a question in the Q&A which says, how do you recommend the use of Rapids Doctor, e.g. pip install? So yeah, so at the moment, Rapids Doctor is not available. It should be available, I think it won't be this. We're doing a Rapids release next week. I think it will be in the next Rapids release, which will just be in the new year. But it will be available via the kind of normal places, Conda and pip. The goal is that like Rapids Doctor itself is this nice lightweight tool, and then the other libraries that exist, QDF, QML, whatever you've chosen to install, will kind of plug in and be available through Rapids Doctor. So if you just install Rapids Doctor as it is and run it, it will check that you've got NVIDIA drivers and CUDA toolkit and kind of standard things. But then if you then go and install QDF, it will run a bunch of like QDF smoke tests as well to make sure QDF is happy and importable and usable and things. So this kind of adds to that ecosystem. Next up is there support for Rapids on the Azure cloud for Azure ML? Yes, absolutely. So if you go to the Rapids documentation, which is just docs.rapids.ai, there's a little section on the menu on the left-hand side, which says deployment docs. If you click that, we have kind of documentation pages on all the major clouds, all the different places. At the end of the day, these are all Python libraries that you can install into various environments. So as long as you can get a GPU and a Python environment, you're good to go.
Yeah, I commented the link in the Q&A section, like if that would be helpful. But yeah, that's where everything, like the deployment doc is.
Perfect, great, okay. So next question from Adrian was, might be out of scope for this talk since it's more about distributing code, but do we know if Rapids currently supports an easy way of fusing kernels? I mean, the various libraries themselves do, have these kernels that have been kind of built and the C++ layer, I guess, like there's a lot of stuff that is being fused together. And if you're writing number code, then you kind of have a bit more control over how your code is being written. But if you're kind of talking about like multiple different libraries kind of fusing together their launches and things, I'm not sure if that's something we support now. As you say, it's kind of out of scope for this talk. I don't know if it's something we can answer directly here. But I would encourage you to, if you go to rapids.ai, there is a link at the bottom to come and join our Slack. It's a great place to come and interact with Rapids developers directly and ask any kind of questions like that. That you might have. Okay, next question is, does Rapids Doctor work without Rapids in the current stack of an app? So a Dockerized project with pip and PyTorch GPU model. Yeah, so in theory, Rapids Doctor is just a standalone tool. You can just install it. It's pure Python. And then libraries plug themselves in. So as I say, it will do basic checks like driver checks, CUDA checks, kind of out of the box. And then in theory, PyTorch could add their own set of checks and they could expose those, and Rapids Doctor will pick those up and run through to make sure that PyTorch is happy in this environment. Because these are the kind of challenges we run into, is maybe you have an environment, you've got PyTorch in it, maybe you've been given a Docker container that already has a PyTorch environment in it, and then you want to come along and pip install QDF, or you want to pip install QML or something. Sometimes you can end up with like slight conflicts because the packaging ecosystem is still growing and developing and moving. And being able to just run Rapids Doctor and be like, oh yeah, okay, all the things I've installed are giving me a green check. So I'm happy that I've successfully put all these things in the same environment. Okay, another question here is, recommended Rapids install now for better dependency management. Okay, so if you're asking kind of what our recommended methods are for installing, again, if you go to that rapids.ai page and click the kind of get started link, it takes you to our documentation. We generally advise that you either start with a Conda environment, a fresh Conda environment, or a fresh kind of Python virtual environment, and install with pip is you're going to have the least number of conflicts if you install everything in one command and let the solver kind of go for it with whatever you need. We also do provide Docker containers that are pre-built with all the Rapids tools in already, and there's like a little selector. You can choose different flavors of the image. But if you have like an existing environment, which is very common, that you like want to add extra Rapids packages to, you can of course use pip or Conda to install those packages as well, and they'll pull them in from PyPI or Conda Forge. But I think the biggest challenge you see, and I think this is true across all of the PyData ecosystem and Python in general, is when you've got an environment that is evolving over time and you're kind of adding a dependency here and adding a dependency there, and you're doing some work and you're, I could do this thing and I'm going to install that. As it grows, like it can get a bit unwieldy, and sometimes it just makes sense to go, okay, I'm going to start a fresh environment with all the things in and I'm going to install it in one go, and I'm going to get in a better state. Okay, great. What else have we got? Okay, another question here is Conda, Pip, poetry, etc. All the things are good. Whatever you like. Conda, Pip, poetry, Pixie, UV, like, you know, the modern stuff. Micromamba is nice. Like, you know, you've basically got two ecosystems, right? You've got the packages that are built and put on PyPI, and you've got the packages that are built and put in CondaForge. Whatever tools you use to interact with those are great. We build packages for both kind of repository locations, and so yeah, whatever flavor you like, really.
There's also a question on leveraging Rapids if using PyTorch.
Yeah, absolutely. So, like, you know, it totally depends what you're using with, you know, what you're doing with PyTorch. But Rapids ultimately has a bunch of libraries that give you GPU acceleration. So maybe you're loading in some data with pandas, doing some manipulation, some feature engineering, some, you know, ETL type stuff, and then converting that into a tensor and then doing some machine learning training. The goal of Rapids is to come in and like replace those earlier libraries or augment those earlier libraries, right? You use the QDF pandas plugin so that all your pandas code is GPU accelerated. The data is already on the GPU. You can kind of manipulate it there, and then just hand directly over to PyTorch afterwards. So yeah, all these things are very composable and plugged together. Okay, and Hugh says, last question. So we're on the last question. Great presentation. We'll be able to get a copy of the slides. Yeah, I'm sure we can put the slides somewhere. That's not a problem at all.
Yeah. I guess thank you all for coming. And if you would like to learn more about Rapids, please check out rapids.ai. We sent a couple of links in the chat. So those are just like great places to get started. But thank you so much for like joining us, and we hope you learn more about Rapids and are excited for Rapids Doctor now.
Absolutely, and enjoy the rest of the conference.
Yeah, have a great conference. Bye.
Thank you, Melody and Jacob, for that fantastic presentation. Next up on the data science track is the hidden costs of data quality, tackling common data challenges in ML with Kale and Prasad. So I hope you will join us there for that next session. And thank you again to both of those awesome speakers. Thank you, everyone.